Everybody have a good weekend? Yeah? All right. Well, I have good news and I have bad news. So what do y'all want first? The bad news? The bad news that we only are going to have 2 more days of lecture. This week is the only new material, so I'm sorry. And the good news is that we only have 2 more days of lecture. And next week, here's our plan. All right, let me write this down so it's documented. Okay. This week, we are going to spend all our time on 5.7 out of the book, which is division of polynomials. We started it last week. We're going to finish it. It's going to take us 2 days. And then next Monday, we're going to call next Monday Makeup Day. So what you have to do is this. If you have a test grade that you want to try to bring up, all right? Maybe you didn't do good on exam 1, maybe exam 2, whatever, exam 3. Right, there's 3 exams that you've taken. Okay? You can come in next Monday and you can make up one of those exams. All right? What you have to do is tell me either today or on Wednesday what exam it is. Well, let's say Wednesday because I don't have a I want to print out everyone and then be able to write down next to your name what you're going to do. So on Wednesday, you let me know what exam you're going to come make up. And then on Monday, you show up, you take that exam, a retake, it's a new exam, right? You do another version of that exam, and then that grade will replace your other exam. Now, if you do worse on the retake, that's the grade, okay? So weigh your options here. If you got an 82 on the, lowest exam is an 82 and you want to try and retake it and you get a 75, it's now a 75, not an 82. All right? Make sense? If you're happy with your exam grades, you get Monday off. If you don't want to come in, you don't have to come in. Okay? Does that make sense to everyone? Okay. So next Monday is makeup day. Next Wednesday is review for final day. All right? I'm going to put here makeup day optional, okay? Because you do not have to make up a test. But there won't be any curves to the grades or anything like that. No bonus at the end of the semester. Just that's your chance to try and bring your grade up, all right? We review for the final, and then that ends the weeks, that ends the semester technically as far as weeks are concerned of class. The following week, okay, so that's this week, that's the following week. The week after that, we have our final, and Monday, the 5th, we have no class, nothing, okay? And then on Wednesday, May 7th, oh, wait a minute, hold on a second. Oops. May 12th. And May 14th is our final. And of course it's here, starts at 9:30, goes to 12:15 p.m. Now that's the amount of time that you will be given for the test. It may not take you that long. What's going to be on the final will be discussed next Wednesday, all right? What I plan on doing is just taking a look at all the grades, taking a look at all the makeup exams, seeing where everyone stands, and then once I do that, I'll figure out what the final is going to kind of be like, and then we'll talk about it on Wednesday. Yes, you'll be able to have a cheat sheet. Yeah. All right. Questions on any of that? Just so you know, on this week right here, it's called finals week, right? All you should be doing in finals week for all of your classes is taking a final. Most classes meet twice a week, right? During finals week, you only meet one of those 2 days. So if your instructor has you coming in on both days, there's something wrong with that, all right? It should only be one of the two. That's why on Wednesday, we don't come in on Monday, but we come in on Wednesday, and notice our class goes from 9:30 to 12:15. So the class, you know, there's a class right after ours, right? Starts at 11. Their final is on Monday. That way this room's empty on Monday for them. But if their teacher has them come on Wednesday, we're going to be in here taking the final. You know what I'm saying? So in the past, I've had students who are like, well, my teacher's having us meet both days. You're actually not supposed to do that. It's only one day, all right? Because it messes all the room scheduling up. Okay, no questions? All right, now questions over any of the homework? Okay, well, let me just remind you of what we were doing last time. We were dividing polynomials. And what we looked at is what happens if you take a polynomial and divide it by a monomial. Monomial is a single term, right? So I gave you an example here. Here's a polynomial on top, divide by a monomial. And what we did was we split this up into 3 separate problems, right? We took the first term, divided it by the monomial here. Second term divided by monomial. Third term divided by monomial. And then we come up with an answer. It's kind of weird looking, but that's the answer, all right? And then I gave you a quiz where you had to multiply a binomial and a trinomial. You had to multiply or expand out a binomial. And then you had to do the division of a polynomial divided by a monomial. I have those quizzes. I can hand them back, all right? I put the grades in this morning. So what we're going to look at is more of this stuff, but we're going to look at the harder cases. The harder cases where this denominator here is not a monomial, where it's either a binomial or a trinomial or just some arbitrary polynomial. So that's where things are going to get a little bit interesting. Okay, so that's what today is about. We're going to call this long division. Long division. All right, so let me take you back, way back, okay? This will be Throwback Monday, all right? We're going to go back to, what if you were asked to find 15 divided by 5, and let's say you're like in, I don't know, 4th grade, 3rd grade? I don't remember when exactly this happens, but it's somewhere around there, okay, before middle school. You're taught to do that. That means you have this division box, right? Remember that? Which number goes inside the division box? The 15. What goes on the outside? The 5. So 5 is the divisor. That's the thing going dividing into this. So what we did is we looked at the 5. We asked ourselves, 5 times what gives us 15? And you go, oh, 3, right? And you put the 3 here. And then you said, all right, 3 times 5 gives us 15. And we put that underneath here. And then we came through and, do you remember this important step? You subtracted that. And then came down and you said 15 minus 15 gives you 0, right? And since we have no remainder, right, that was called the remainder, then the answer would be just the 3. Now, I understand everyone knows the answer was 3 to start off. But this process of what we did here is what we're going to do today. All right, so we need to make sure we understand how it all works. What if we did something a little more interesting like 150 divided by 4? So we would make our division box. 150 goes here, 4 goes here. And then what we did, hopefully, what you did is you said, can 4 go into 1? No. Can 4 go into 15? Yes? How many times? 3 times, but not, it's not exactly 15, right? 3 times 4 gives us 12. What about, could I have done 4 times 4? No, because 4 would have given us 16, so it's too big. So we put a 3 here, right? Then you multiply down. 3 times 4 gives you 12. And then you came through and you did subtraction, right? And because there was nothing here, you just put a 0. And you subtract straight down, and what would you get? Well, 0 minus 0 is nothing, right? 5 take away 2 is 3, right? And 1 minus 1 is 0. So you just get a 30, right? And you say, all right, how many times does 4 go into 3? Well, it doesn't. How many times does 4 go into 30? 7 times without going over. So 7, so we put a 7 here. Then you take that 7, right, and you multiply times the 4. 7 times 4 gives us 28. You put that here. You come through, you subtract. How many are left? 2. Then you say, can 4 go into 2? No. So then way back when you would say remainder 2, right? Do you remember that? Or you would say this. After you were taught remainder, maybe you were taught to put 37 and then the 2, right? The 2 divided by whatever your divisor was, 4. So instead of saying 37 remainder 2, you were taught 37 and 2/4. What's 2/4 though? Reduce that fraction, 1/2. So maybe you wrote instead a final answer of 37 1/2. 37 and a half, right? Now, just to be clear, this is called a mixed number. And we don't like mixed numbers because a lot of people don't understand what a mixed number really means. What this means, so we're all clear, 37 plus a half. That's what that means. Okay? All right. That's the setup for where we're headed now, okay? Just to get us thinking long division again. That's what long division is back in grade school. Now, long division now is going to look like this. So let's take x squared minus 3x minus 4. Let's divide that by x minus 4. Okay, here's our first example of how we're going to employ polynomial division or long division with something where we have our divisor is not a monomial. Do y'all see that? X minus 4, it's not a monomial. It's a binomial, right? Okay, if it was a monomial, this would be just split it up into how many different fractions? 3, right? But because it's a binomial, you cannot do that. So here's what you do instead. You make sure, well, you draw a division box. Give yourself some room here, everyone. Okay? Draw a division box. This. Okay? And you're going to put the numerator into this division box, making sure it is in descending order. Remember what descending order was? Highest power of x down. Okay? Highest power of x down, which is the way it's written. X squared minus 3x minus 4. And then on the outside, you're going to put the divisor, again, in descending order, which it is in descending order, x minus 4. All right, now, what we did in the previous example, I'll just throw it back up here, is 150 divided by 4. We asked ourselves, what do we multiply 4 by, 4 by to get 1? And we said it couldn't. And 4 to get a 15, we said 3, right? We're going to do something like that here. What we're going to do is we're going to focus all of our attention on just the first term of what we're dividing by, which is x, okay? All of our attention is on the x. We don't care about the 4 right now. And we are going to look at just the first term of what we're dividing into, which is the x squared. And we are going to ask ourselves, what do I need to multiply x by to create an x squared? An x, right? X times x would give me x squared. So what I will do is I will put an x on the top. Now, where you put the x on top doesn't really matter, but a lot of people like to line them up. Notice how this x is on top of where this x is. Instead of putting the x above the x squared or the x above the 4, negative 4. This, you don't have to. You put the x anywhere up here, but I'm going to just line things up. Okay. Going back over here to our 4 and our 15, once we said 3 up here, what did we do after we had the 3? We multiplied the 3 times the 4 and put that answer down here, didn't we? So we said 3 times 4 is 12. We put 12 underneath. Here, I'm going to do the same thing. I'm going to get that green stuff out of there. I'm going to take the x, and I'm going to multiply it times this, and put the answer underneath here. So I'll do that on the side like scratch work. I'm taking my x up here, and I'm multiplying it times what? X minus 4, the whole thing. So I'm going to put that in parentheses over here, because if you're going to multiply x times x minus 4, this is what you have to do, right? And this is now polynomial multiplication. To multiply those two things, I have to distribute the x through the parentheses. So distribute the x, I get x squared minus 4x. Any questions? No? Okay, so that's what I get when I multiply. I need to put that underneath over here, don't I? So let's put that now. Line things up. I have an x squared. Put it right underneath the x squared. I have a minus 4x. Let's put it underneath the x, or the negative 3x. So far, so good? We all right? Questions? Okay, what did we do? Up here we did 3 times 4. That gave us 12, right? But then what did we do? We subtracted it, didn't we? We came in and we said, oh, I'm going to take that 12, I'm going to subtract it. We have to do the exact same thing right now. We have to come in here and we say, oh, we're going to take that and we're going to subtract it. What do you think subtracting this does? But I mean, this was an x squared, right? If I want to subtract it, doesn't that make it a negative x squared? Doesn't it? And if this was a minus 4x and I'm subtracting a minus, doesn't that make it a plus? Yes? So every time you do this step, whatever you get here, you're going to come through and you're going to subtract it. It's going to change the signs. So it's going to become a plus, oh, sorry, not plus, a minus x squared. Make it real big so you can see it. And then over here, it was a minus, right? I'm going to make it a big old plus. And I exaggerate the heck out of these because I want you to realize they change signs. And now, go down with it. So just go down. These are like columns, okay? You have 1 column, 2 column, 3 column. Just go down and just add straight down. I'm not going to say subtract down because we already did the subtraction, right? We did the minus, we changed the signs. So just go ahead and go down with those. What's x squared? Take away x squared. Nothing, right? Okay. What's negative 3x? Add 4x. That's just an x, right? 1x. So I'm just going to put x. All right, and then what's right here? A 0, right? I don't need to write it, but that's a 0 there. What's negative 4 plus nothing? Still negative 4. Okay? Questions? I'm going to go back up to the top right-hand corner. When we did that step up here, we were left with the 30, weren't we? Up here? And then we said 4 goes into 30 how many times? We said 7, and then we did it again, didn't we? Well, we have an x minus 4 down here. I'm going to focus again all my attention on the first term here, the x, and then the first term here, x again. I'm going to say, how do I turn an x into an x? How do you turn x into x? Multiply by 1, right? Positive 1. X times 1 is x. So what I need to do is up here on the top, I need to put a plus 1 up there. Now on the side again, I'm going to set this up and do my scratch work. I did a 1, and I'm multiplying that times the x minus 4. So that's this 1. I'm going to make it multiply times the x minus 4. Just like up here on the top right, I would have done a 7 up here, and then I would have multiplied through and put a 28 underneath, right? Just like that. I put my 1, multiply it through. What's 1 times x minus 4? It's just still x minus 4. And where do I put that? Where do I put 1 times x minus 4? Where does it go? Underneath this x minus 4. Y'all notice they're exactly the same thing? Okay. So I put my x minus 4 here. I come through and I subtract it. When I subtract it, what happens? It becomes, this one is minus, now becomes minus, and this one becomes a plus, right? Changes signs. And now you have 2 little columns here. Let's add down on those. What's x take away x? 0. What's negative 4 plus 4? 0, which means I have a remainder of 0, which means there's nothing left over, right? Which means the answer is up here, x plus 1. See, that's a little more involved, right, than the monomials, this long division. Questions? I want you to think about something for a second. When we said 15 divided by 3, was it 3? Yeah. Everyone said the answer to that was 5, right? I want you to look at something. Isn't that true because 3 times 5 is 15? In other words, if I take this divisor and this 5 and I multiply them, I should get back what's up here, right? Well, we just said in the previous problem is that x squared minus 3x minus 4 divided by x minus 4 turned out to be what? X plus 1. What this means is that this denominator times this should equal what's up here. See, it's the same color coding I'm doing here. So this means that the x minus 4 times the x plus 1 should be equal to the x squared minus 3x minus 4. Do you all see how this is pretty much the same setup here and here? This and this equal this. And how could we check that that's true? I could take this right here and multiply. It's 2 binomials. So you would do that FOIL thing, which I said I don't like FOIL, but you take the x. What's x times x? X squared. Then you do x times 1, which is x. Then you do negative 4 times x. That's negative 4x. Then you do negative 4 and 1. You get minus 4. Put your middle 2 terms together because they're like terms. And you get x squared minus 3x minus 4, which is this. Okay? Now, for those of you who are going to go on and take the next class after this, 320, this is kind of what you'll be doing. You'll be starting with this over here on the right side, and you'll be trying to turn it into this on the left side. That's called factoring, going from here to here. So what I've done is I've actually showed you a way that you can kind of try and factor something. Because we were able to break this up here down to be these 2 things. But that's for another class. I just want to kind of give you a little preview there. All right, let's try something a little more complicated. Not too much more though, right? We don't want to go crazy here today. How about (3x squared plus 2x minus 5 over x plus 2. Not exactly the type of stuff you want to do on a Monday morning, right? All right, can we use that one where we just split it into three? You know what I'm saying? Where we just do this over the bottom, this over the bottom, this over the bottom. No, because we have binomial in the bottom, so we have to use long division. All right, so let's go and set it up. Let's see, what goes in the box? Okay, 3x squared, and is it in the right order right there, like that? Yes? Okay. All right, outside, x plus 2, in that order, right? Okay, what is the first thing that I focus my attention on? The x on the outside and the 3x squared on the inside. And you ask yourself, what do I multiply x by to turn it into this? I need a 3, right? And I need an x. So 3x. And I'll go ahead and put that up on the top of the box, and I'm going to put it right above the 2x, just to line things up. 3x, and that should get it. So on the side here, let me see. I'm doing 3x times what? X plus 2. Let's distribute that through. We get 3x squared plus 6x. Understand what I'm doing? Okay, now where do I put that? Underneath the stuff in the box, right? So I put 3x squared plus 6x, lining things up, right? Very important that you line things up. The x squareds go together, the x's go together, right? What's my next very important step? Change the sign. So the positive 3x squared becomes a minus, and then the positive here becomes a minus 2. See, I just do this like very overpowering minus sign, just kind of wiped out that plus. And now come straight down with things. When you do this, if you do it correctly, the first term should always go away. I mean, that's the whole idea, is to make that 3x squared cancel. If something happens and that doesn't cancel, you messed up with something. So the 3x squareds go away, right? Then you have 2x take away 6x is what? Negative 4x. And then the negative 5 comes down. There's nothing here with it, right? So just minus 5. All right. Now what are you looking at? The x and the negative 4x, right? You're trying to say, how can I change that x in front into a negative 4x? So what's the only thing I need? A negative 4. And I will put that up here, minus 4. And then on the side, I'm going to do my scratch work again. I'm going to put over here my negative 4, and I'm going to multiply that times that divisor, x plus 2. I distribute negative 4x minus 8. And where's that headed? Underneath that 4x minus 5. The negative 4x minus 5. So I put negative 4x. I put minus 8 here. Then I come through and change the signs. Make it plus, plus, and then add down. What do you get when you add down? Just a 3, right? Okay. Now what? Yeah, see, here's the thing. Our x here, if we're asked to try and change it into a 3, we can't do that, right? How are we going to turn x into 3? The 3 doesn't have any x's there, right? Also, another indication that we're done is the fact that we've come to the end of this division box. You see that? Like, we can't go any further. There's nothing else we can put over here because the 5 is where we end. Does that kind of make sense? So yes, the 3 is the remainder. So how do we write it? Well, this is not correct, but I'll put it just so you know. Remainder 3. That's not the way we'll write it. The way we're always going to write it is this. We will always put a plus sign, regardless of what's there. Then we will take our 3, our remainder, and then over, what do you think? X plus 2, our divisor. So whatever your last term up here will always be your remainder over your divisor. Remainder over your divisor with a plus sign in between them. And that is our answer. Just like that. Okay? It's kind of like this one right here. I said if we got a remainder of 2, we didn't write remainder 2. We put the answer and then 2 over 4, which was 1/2. But I said not many people know what that means. It really means there's a plus sign between them. So that's why I'm putting the plus sign between them. Questions? I still have to show you some more because things can get a little weird, like the next example. Okay, let's do 4 minus x squared plus x cubed over 2 plus x squared. All right, you look at this and you have to realize you have polynomial division here. Polynomial, actually it's a trinomial, right? 3 terms divided by 2 terms. And so you can't do the quick and easy division, you have to do long division. So I'm going to set up my division box. Now, let's be very careful here. What goes in the division box? Descending order. Descending order, right? So what goes first? X cubed. What comes next? Minus x squared. And then we have a plus 4, right? Okay. I need y'all to wake up for just a second. Not like you were sleeping, but here, this will help. That's not very loud, is it? That doesn't, never mind. I guess you're all awake. I'm going to try and like scare everyone awake. Don't screw this part up, okay? It's an extremely important step of this problem. Right now, I have an x cubed, right? I have an x squared. Do I have an x term? I do not. But with long division, you must always account for that space, okay? You don't realize it now, but you may need that column so you can put x's in a position later on in the problem. So what we're going to do is be clever here. We're going to put up here a plus 0x. And that's just a 0, okay? It's just a space. And then after that, I will put my plus 4. Do y'all see that space? One of the biggest issues I see with students is that they will forget the space, and then everything gets all messed up with the lining of things, and it's a disaster after that. So if there is a missing power, make sure you put a 0 there. Okay? Now on the outside, what do we have? In descending order, x squared. Now, on the outside, you do not need a 0. I know that can be confusing, but notice we don't have an x term on the outside, right? We have x squared, but we don't have x. On the outside, you just leave it the way it is, plus 2. But it does have to be in descending order, all right? We okay with that? All right, now let's get things going here. I'm going to look at the first term, x squared. I need to turn that into x cubed. How do I turn x squared into x cubed? Multiply by x. I'll go ahead and throw that x right up here on top right there, just like that. See? And now over here on the side, I'm going to do x times x squared plus 2. Distribute x cubed plus 2x. Everyone agree? Now, we need to put that underneath on the right side. So I'm going to put my x cubed underneath the, x cubed, right? Okay, where am I going to put my positive 2x? Under the 0x. Because this is where my x's go. These are where my x squareds go. Do I have any x squareds? No. I have a 2x, so I need to put that 2x right here. Do you see why if you did not have that space, you wouldn't have anywhere to put that? Was it minus? Yeah. I'm showing you what would have happened had you done it this way and forgot the space. You still would have said, okay, here's x cubed, here comes my x. All right, I'll just throw it there and then multiply those, you get an x cubed, and then I have a 2x, so where does the 2x go? You see? I can't put it under the x squared because it's not a squared term, so you can't put them together. So you're kind of like stuck and you're trying to figure out where to put this thing. Y'all follow? Okay. Okay, so now I come through, I will subtract this row, which means change the sign. So minus here. That was a plus 2x, wasn't it? I'm going to make it a minus now. And now we go straight down with things. X cubed, take away x cubed is nothing. What's next, though? What about that negative x squared? Bring it straight down, right? There's nothing there to put it together with. So x squared plus nothing, a negative x squared plus nothing is still negative x squared. What is nothing take away 2x? Negative 2x. And then what is 4 and nothing? So positive 4. Okay. And we continue. X squared needs to be turned into negative x squared. So what do I need to turn an x squared into a negative x squared? Minus 1. I put that right up there. Now, see how that lined up? So we kind of know right now this is our last long division step, right? Because I've come to the end here where there's a 1 over the 4. So I know I'm going to stop after this. And whatever I get at the end of this is my remainder. So on the side here, let's do the negative 1 times the divisor, x squared plus 2. That will give us negative x squared minus 2. I put that underneath here. So I'm going to take my negative x squared and put it right underneath my negative x squared. I'm going to put my minus 2 underneath the what? Positive 4. I will come through. I will subtract this row, which changes my negatives to positives. Plus, plus, and now we add down. What is negative x squared plus x squared? It's gone, right? How about this right here? Bring it straight down, negative 2x. And then 4 plus 2, 6. Now, you know that you're going to stop right now because I told you you were at the end up here, right? But you can also look at it this way. You cannot turn x squared into 2x or negative 2x because the power here is lower, isn't it? So you can't do it. So what we will now say is, what do I put up here next to the 1? Plus, always a plus, okay? And then I'm going to create a fraction. It'll be whatever my remainder was, which is what? Negative 2x plus 6 over x squared plus 2, my divisor. And that is the answer. Whoa. Okay. One more, I promise. One more, and then I'm going to give you some to try. 8 minus x cubed over 4 minus x squared. First thing that you should check, all right, is the denominator a monomial? It is not, right? It's not a monomial. It's a binomial, so we have to use long division. I'm going to set up my long division. And I need to make sure that I put my numerator in descending order. So what would come first? What is it? X cubed or negative x cubed, right? Now, what? Plus 8? Okay, we don't have an x squared, do we? So plus 0x squared. Now plus 8? No, because we don't have an x. So we need another one of these zeros. Then plus 8? Yes. Okay, what about on the outside? Negative x squared plus 4 in descending order, right? All right, here we go. Turn negative x squared into negative x cubed. What do we need? An x? Line it up there over the x's. I come over here, I put x times negative x squared plus 4. That gives me negative x cubed plus 4x. And now let's go put that stuff underneath the appropriate locations here. So negative x cubed will go beneath the negative x cubed. And then 4x, positive 4x, will line up underneath that 0x. I come through, I change signs. Positive x cubed, and this now becomes a negative negative 4x. Let's add down. What do you get? Cancel. What do you get? Negative 4x plus 8, right? Oops. 8. Yeah, because can you turn negative x squared into negative 4x? No, because the x squared, the power is higher. So that's it. We're done. All right? Now, I know you might be saying, wait a minute, we didn't get all the way out here. That's okay. If you get all the way to the outside, then you know you have to stop. It could happen sooner, like it just did. So we put next to this plus our remainder over our divisor. And we are done. Okay, here's what I'd like for you to practice, all right? I want you to work on it. I don't think I'm going to collect it. I'm just going to kind of come around and see where you are on it. Okay. Your homework, by the way, is page 401. '27, 31, 35, 41, 43, and 47. And what I'd like for you to do right now is (9y plus 18y squared minus 20). I'm going to give this to you the way the book wrote it, divided by 3y plus 4. And then I'd like for you to do n to the fourth minus 16 divided by n minus 2. Okay, that's the way the book presents the problems to you. Does everyone understand that the term or the polynomial on the right side, that's the denominator, that's the bottom? This is the top, that's the bottom. This is the top, that's the bottom. Okay, so do those two. See what you get. Raise your hand when you get to an answer. If it looks good, I will mark you down as being here, and I will let you go. Okay? Uh-oh.